Dear friends, architects, engineers and consultants and students, once again, welcome to VK Jain Sir ki MEP classes. Uh, this particular series is about fire services. Uh, we'll be discussing throughout this series the total gaseous fire suppression systems. As you know, we have already water sprinkler system. What water sprinkler system normally destroys the contents of the enclosure where the fire has existed due to spray of water. So people were trying to find out solutions which does not destroy the surroundings, and they have come to conclusion about total gaseous fire suppression system. So we'll continue. Okay. Dear friends, there are four means used by the agents to extinguish a fire. They act on the fire tetrahedron. We have already learned about the fire tetrahedron. The first one is by reduction or isolation of fuel. This is one part of the uh, fire tetrahedron. No agent currently use this as the primary means of fire suppression except putting electricity off or stopping gas or oil cylinder. The second one of the fire tetrahedron is reduction of heat. Representative agents are clean agent FS 49C2, uh, popularly known as FM200, and Novak 1230, and many more. The third method is reduction or isolation of oxygen. Representative agents are argonite, CO2, and Ig541 Inergen systems. The fourth element of fire tetrahedron was inhibiting the chain reaction of the above components. In this category, there are um, several agents which have become popular by time. We'll continue further. Dear friends, broadly speaking, there are two methods for applying an extinguishing agent. One is by total flooding and second is by local application. System working on a total flooding principle apply an extinguishing agent to a three-dimensional enclosed space in order to achieve a concentration of agent volume percent of the agent in the air adequate to extinguish the fire. This type of system may be operated automatically by detection and related control or manually by operation of a system actuator. System working on a local application principle apply an extinguishing agent directly onto a fire, usually a two-dimensional area, or into the three-dimensional region immediately surrounding the substance or object on fire. The main difference in local application from total flooding design is the absence of physical barriers enclosing the fire space. Okay. Friends, we are discussing total fire suppression systems. The fire suppression system can be gas based, water based, or water based. Gas based systems are that use gaseous agent as fire suppression media such as All agents alternate to Helen gases listed on and approved by used by Indian standards. Other methods are types of gas-based system where their protection is equal to or better than what is suggested above for the type of application subject to acceptance of authorities concerned may also fall under such system. Second category is water-based systems. Systems that use mainly water as firefighting extinguisher, such as hydrant system, sprinkler system, water spray system, foam system, and water mist system. Total gaseous system extinguish the fire by flooding the entire protected enclosure with gas, reducing oxygen or interrupting the chemical chain reaction without damaging equipment of the enclosure. They are widely used in one server room, data center, electrical panel, archives and libraries, clean rooms, and UPS room. Dear friends, we were discussing total flooding system out of which the first one is implying clean chemical agents. These agents may be HFC or and Novec. This suppresses fire by absorbing heat or breaking chemical reaction. Common agents are common clean agents are FM200, that is a HFC 227EA, the formula, chemical formula. Second one is Novec 1230 and HFC blend, less common now. The characteristic features of these agents are they discharge in 10 seconds, safe for electronic equipment. No residue will be left after applying this total flooding system. Requires sealed room. Door fan test recommended. Stored as liquefied gas that leaves smaller cylindrical footprint. Dear friends, the second total flooding system is known as applying inert gas systems. The inert gas system lower oxygen concentration to 12-15%, safe for humans for short exposure. Common agents are IG 541, better known as Inergen, IG 55, and IG 100, that is pure nitrogen. The characteristic feature are they are environment friendly, ideal for occupied spaces. Large cylinders are needed. Discharge in 60 seconds. They are slow and safe. Friends, now we are discussing Helen type of system. These are total gaseous fire suppression, total flooding systems known as total flooding Helen systems. These were very popular previously, but later on they were discarded for use due to oxygen depletion. Now, total flooding system extinguish fire by releasing halon gas throughout the entire enclosed room, rapidly suppressing flame while interrupting the chemical chain reaction. Now, what is halon? Two main types were used. Halon 1301, known as BTM, used for fixed total flooding system. Second is halon 1211 BCF, used for portable extinguishing system. The characteristic feature of the halon application is they provide a very fast discharge in zero point 0.2 to zero point 0.5 seconds. They are very effective on class A, B and C fires. Leaves no residue. Safe for sensitive electronic equipment. Does not require perfectly sealed rooms like unlike inert gases. Dear friends, I have in the previous slide description told you that halon systems are no more recommended. Uh, we'll discuss current regulatory status. They are phased out. Halon production is banned worldwide by the Montreal Protocol 1987 due to ozone depletion. India banned introduction under ozone depleting substances regulation and control rules 2000. NVC 2016 requirement dictates halogen systems shall not be used for new installations, only allowed in aviation and military defense critical equipment and some legacy systems. Grandfathered replacement system must be used for all commercial building. To how total flooding halon system works, principle of operation. Halon extinguishes fire mainly by breaking the chemical chain reaction in the flame zone. Minor cooling and oxygen reduction also happens. Discharging halon 1301 is banned through as it is discharged through nozzles installed across the room. System activate through smoke detectors, heat detectors, or manual pull stations. Automatic solenoid valve. Discharge time is less than 10 seconds. Very fast. Concentration level. Typical extinguishing concentration is 5 to 7% by volume. Safe exposure limit exceeded about 10%. Through this slide, dear friends, we will revise whatever we have learned so far. Localized or total flooding fire system. These fire extinguishing systems are sometimes used in conjunction with conjunction with very early warning detection system that permit manual intervention for in advance to automatic application of an extinguishing agent. The methods are through one water spray, two pre-action water sprinkler system, third deluge water sprinkler system, fourth foam water sprinkler system. Will I will tell you deluge water system, water mist system for gas turbines and similar machinery. Now, these systems are activated or by applying carbon dioxide total flooding, clean agent, we have learned Helen 13.0 BTM or 1211 BCF. Both are banned due to ozone depletion. FM 200 or Fe 227. This is HFC derivative. Fe 15 Ergotech trade name. Inergen gas blend. Friends, this slide shows you a bank of cylinder tied together so as to use as gaseous fire extinguishing system. Friends, once again some more points about gaseous fire suppression system is a term to describe the use of inert gases and chemical agents to extinguish a fire, also called clean agent fire suppression systems. Gaseous clean agents have for many years been a recognized effective medium for the extinction of flammable liquid fires and fires in the presence of electrical and ordinary class A hazard. But it should not be forgotten in the planning of comprehensive scheme that there may be hazard for which these media are not suitable, or that in certain circumstances or situations there may be dangers in their use by use requiring special precautions. Hello friends, the Indian standard 15493 of year 2004, known as gaseous fire extinguishing system general requirement. This standard covers the general requirement applicable to total flooding clean agent systems like halocarbon agent and inert gas agents. Clean agent, electrically non-conductive, vaporizing, or gaseous clean agent that does not leave a residue upon evaporation. The word agent here ever appearing in this document shall mean as clean agent. These are also governed by NFPA standard for clean agent fire extinguishing system known as NFPA 2001, and they are applicable in USA and world over. These systems are recommended and become applicable within enclosures such as rooms, walls, enclosed machines, containers, storage tanks, and bins. This is for all very big application. For enclosed electrical hazard such as transformers, control cubicles, switchboards, circuit breaker, and rotating equipment. Third, for enclosed flammable liquid gas storage and processing areas. Fourth, the engines using flammable fuels. Fifth, for electronic hazards such as computers, data processing equipment, control room, telecommunication facilities, etc. Sixth, They are used for subfloors and other concealed applications. And last, other area where we are having high value assets. Dear friends, we'll discuss why clean agent fire suppression systems are deployed. The data loss and downtime are the two most costly problems that can affect a business. A fire in a computer center, transformer room, or some other critical area can have enormous consequences and as a result a long period of downtime. Therefore, in many cases, these rooms are protected with automatic gas extinguishing systems, whatever we have been reading. Uh, we'll once again summarize them because they are very, very important. There are various clean agents, fire suppression systems or gas suppression systems in the market. One is argon gas suppression system or argon clean agent systems. Second is FM 200 clean agent systems. FM means factory mutual. These are the standards. Third is Novak 1230 clean agent system. Fourth is FE13 clean agent system. And last, carbon dioxide system, clean agent system. Friends, let me tell you that the last one, carbon dioxide clean agent system, was suggested and utilized by me in Sena Bhavan when I was in charge of that area, executive engineer in charge of that area, approximately in 1977. Friends, the isometric view provided in this slide shows a typical clean agent system layout. You have a cylinder, clean agent cylinder, and you have a nozzle or a series of nozzles. This only one nozzle is shown, and remaining are the support systems. Through a control panel or manual release and abort system, the nozzle discharges the gas in the area, and before that, it provides a warning sign and alarm. All this system is activated when a smoke detector provided in the area ascertains the existence of a large fire in the system. One of the very effective clean gas total discharge system is known as FM 200. It's a trademark. FM 200 is a clean, colorless, and environment friendly fire suppression agent that is electrically non-conductive and safe for humans. It extinguishes flames primarily through heat absorption, having no residue, leaving no residue. FM 200 is used widely because it has a zero ozone depleting potential and low global warming potential. These are the two indicators. The clean agent FireMaster 200 is widely used as a substitute for halon. Halon 1301 BTM is an effective fire supplement and has been widely used in total flooding gas protection systems early to to year 2000. The physical and chemical property of FM are not the same as BTM, slight difference. The extinguishing performance of FM 200 appears to be not so quick as BTM. It is slightly slow. Friends, Novak 1230 is another substitute for halon replacement. It has a very low global warming potential. Novak 1230 is manufactured by 3M. It is generally used in situations where water from a fire sprinkler would damage expensive equipment or where water-based fire potential is impracticable, such as museums, banks, clean rooms, and hospitals. 3M's Novak 1230 fluid does not deplete ozone, 0 ODP, and has a global warming potential of 1 over 100 years, averaged over 100 years. It is equivalent to that of carbon dioxide. Friends, Novak 1230 is ideal for use in total flooding applications, localized flooding applications, and directional spray type applications, and may be used in portable extinguishers for specialized applications. But in addition to conventional method of superpressurization using nitrogen, Novec 1230 fluid also lends itself for use in pump applications because it is a liquid. Novec 1230 is very latest development in extinguishing gases attacking the fire by chemical means. Fire are extinguished with concentration normally below 6%. The advantage of Novec system is that it requires less space and that normally no overpressure venting is required. Friends, the Inergen gaseous system is an inert gaseous fire suppressant consisting of natural gases and extinguishing fire without causing harm to people, property, and environment. Exclusively available through Vermal Inergen, it, a patent. Com- it has a composition of safe gases, including nitrogen, argon, and carbon dioxide, that naturally occur within the normal atmosphere we breathe. Inergen is a mixture of 52% of nitrogen, 40% of argon, and 8% of carbon dioxide. However, in event of a fire, when Inergen is discharged, it mixes with the air present in the room to create a mixture that comprises of 67% of nitrogen and 12.5% oxygen and 17% argon and 32% of carbon dioxide. The Inergen fire suppression also has no adverse effect on ozone layer and as it is completely made up of naturally occurring gases. Inergen fire suppression system also have a zero global warming potential. Friends, this is just to show that inert gas is cheaper than Novec and for large facilities and where long pipe runs are required, inert gas normally offers the most cost effective solution. This slide shows the comparison between different clean agent systems and their parameters. Now, if we see these four, first class A, first class C, local application and alternative to Helen. The carbon dioxide, clean agent systems and this argon clean agent system and Fe3, they have all this one, but carbon dioxide clean agent system may be slightly cheaper. Friends, this particular slide shows us a fixed type carbon dioxide extinguishing system. This may be of two different types, total flooding and local application. In both the cases, you will see the fire cylinders filled with the CO2, and this is the control panel, and this control panel detects fire through fire fire alarm system, of this. These are the fire detectors, 1, 2, 3, 4, and these are the nozzles through which CO2 will get discharged into the system, and this acts very fast. Within a second, it will flood the complete room and extinguish the fire. The detection is happens with minimum four fire alarm system, four detectors working together. I told in the previous slide that fixed fire CO2 extinguishing system may be of two types: total flooding, which acts and fill the CO2 in entire room or any confined area. In the local application, applying CO2 over the surface of the tank. For larger area, there is another system which is known as CO2 high pressure type. Carbon dioxide is non-corrosive, odorless and colorless gas. During discharge, it presents a white fog. It does not make system dirty or otherwise negatively affect the materials with which it comes into contact. The principle of extinguishment is dual. CO2 acts by suffocation or oxygen dilution and reducing the concentration of oxygen present in the area, and why that cooling is caused due to rapid expansion of the gas. CO2 oxide dioxide must not be used for protecting normally occupied areas, since installation can cause asphyxia even at low concentration. Therefore, a signal must be given, voice signal and visual signal both. Furthermore, visibility is greatly reduced during discharge due to formation of CO2 fog. This extinguishing agent can be used in normally unoccupied area if suitable safety devices are installed. Friends, let me tell you the advantage of CO2 firefighting system. The first is very low refilling cost. Second, for use in total flooding system and for local application, two ways. Third, suitable for use in presence of deep-seated fires. Fourth, it leaves no residue after discharge. Fifth, it does not contribute to depleting the ozone layer. Next, does not conduct electricity. Next, form no decomposition product in contact with flame. The last, CO2 is the extinguishing gas most widely used in industrial applications. Friends, now we are discussing dry chemical fire extinguishing system, known as DCP system of dry chemical protection systems. They use pressurized dye powder like sodium bicarbonate or monoammonium phosphate to quickly smother fires by cutting off oxygen and interrupting the chemical reaction, making them effective for class A, B, and C fires, especially in high risk areas like factories, labs, and marine vessels where water might be problematic, offering fast, reliable, and automated fire protection system. Dry chemical extinguishers put off fire by coating the fuel with a thin layer of dust, separating the fuel from the oxygen in the air. The powder also works by interrupting the chemical reaction of fire, so these extinguishers are extremely effective at putting out fire. The fire extinguishers available in two main categories. It is suitable for ABC or BC. These extinguishers will be found in variety of locations. New buildings will have them located in public hallways. They mostly found in laboratories, mechanical rooms, break rooms, storage areas, offices, university, and vehicles. Friends, in the previous slide, I told you about uh, carbon dioxide system working on cylinder carbon dioxide systems suitable for A, B, C category. But this particular diagram here is a dry chemical extinguisher with powder designed for class B and C fires and may be located in places such as commercial kitchen or areas with flammable liquids. Advantage is speed, rapid fire extinguishing at source, versatility, effective on multiple class fire. It can work on ABC, not the above cylinder, some other cylinders. Reliability, less susceptible to extreme temperature than normally existing. Easy installation can be retrofitted into existing structures. The Franks, the foam fire extinguishing systems are applied in the area which are surface areas which are in vertical formation. This can be of two types, fixed type and portable. The fixed type activation with the detector head as shown here and installed in high hazard areas. Portable type is provided in fire departments. Here foam fire extinguishing system will describe in next slide also. Friends, foam firefighting system is a system of firefighting where water is not used. In certain cases, water can actually cause the spread of fire, example, electrical fire or petroleum-based fires. Here, automated fire protection is critical and has to be provided. Yet, water should not be used. This challenge is met by the fire protection foam type. To sustain a fire, we require three things: fuel, ignition, or spark, and oxygen. These three elements form the basis of fire, also referred to as a fire tangle. If one of the elements is missing, the fire will not exist. Fire protection foam systems isolate the oxygen from fire or fuel. When the foam sprinkler detects that there is a fire present, it is triggered. This causes the water to flow into bladder tank. The foam concentrate goes into the bladder tank via the proportioner. The proportioner maintains and keeps in check the desired percentage of foam. The foam is formed when foam concentrate and water mix in a right proportion. The foam passes through the pipes under pressure and directly on the fuel or fire through the sprinkler. The foam covers the fuel like a blanket and isolates the oxygen. The fire triangle is now broken. There are two type of foams: aqueous film forming foam. This is a high quality foam. It is popularly used in refineries, airports, and manufacturing plants. They can be used in variety of media. They are hence versatile. The second category is high expansion foam. They are used in very large areas. Along with the area, they also cover a sizable height. Hence, also used to provide three-dimensional protection in areas like warehouses and ships. They seem to be very effective where spillage or hydrocarbon fire might take place. Friends, there are four types of foam water spray systems. First one, wet pipe system. Second, dry pipe system. Third, deluge systems. And fourth, pre-action systems. The wet pipe spray system is a sprinkler system implying automatic sprinkler or nozzle that are connected with a piping system that contains water. Hence, water all the time, hence known as wet pipe systems. The other type we'll learn in the next presentation. Now we'll learn about other three systems. Dry pipe spray system is a system implying automatic sprinkler nozzle that are connected with a piping system that contains air or nitrogen under pressure, the release of which permits water pressure to open a valve. The next category is pre-action spray system, a sprinkler system to to the dry pipe spray system with the addition of supplemental detection system installed in the same area as the sprinkler. Pre-action systems are generally used in areas where damage from inadvertent operation of water spray system must be avoided. Pre-action system generally divides into two groups. One, single interlock pre-action system, and the second, double interlock pre-action system. Double interlock pre-action system require two independent events in order to activate. Firstly, the sprinkler piping loses air or nitrogen pressure due to operation of one or more sprinkler. And secondly, the solenoid valve is triggered by the operation of a fire detection and device. Friends, the deluge water spray system is similar to water type deluge spray systems. A sprinkler system similar to wet pipe spray system with the exception of employing open discharge devices. The foam deluge system sprinkler heads are open and the pipe is not pressurized with air. Foam deluge systems are connected to a water supply through a deluge valve that is opened by operation of a smoke or heat detecting system. Foam is mixed here in which the water supply from a foam bladder tank. This is the foam bladder tank. The detection system is installed in the same area as in a sprinkler. When the detection system is activated, foam water discharges through all the sprinkler heads in the systems like this. Deluge systems are used in places that are considered high hazard areas such as power plants, offshore oil rigs, aircraft hangars, and chemical storage or processing facilities. Friends, this slide shows you a deluge fire sprinkler system installed for a petrol tank, a big size petrol tanks, and circular valves are provided circular formation at several different heights. The water comes up and spreads the fire, uh, extinguishes the fire. Friends, I am discussing now foam water spray system for fire protection as per NFPA 16, which is American standard. Foam water supply spray system can be used for a combination of class A and V hazards. They are mostly applicable to protection of two-dimensional flammable liquid hazards. The next portion of this we have already discussed.